Hello everyone. This is an introductory video regarding the AXI protocol. In this video, you are going to learn what was the need of AXI protocol, what exactly is AXI protocol, what are the characteristics of AXI protocol, and the architecture of AXI protocol. So we'll be starting with one case scenario. Let us say I have one CPU and one memory. My CPU is acting as a master. My memory is acting as a slave. Now my CPU wants to connect through to the memory, and I want to establish a one connection between them. So there are some requirements for this connection for me. I need a standardization for this connection. Let us say today I have one CPU. To this CPU I'm having one port over here. I bought one memory from market. I have connected it to memory 1. Now this memory was connected using these slots. Now tomorrow my memory got damaged and I want to connect memory 2 to this CPU. So what if these ports are different for memory 1 and memory 2? So over here I need one standardization of signals. So when we say the standardization of signals, exactly we are talking about a protocol or a set of rules which will be followed during the transaction. So I need one standard protocol. Second, my need is I want a high speed data transfer from CPU to memory. The memory contains a lot of data and CPU want to process this data. So whatever the data was here, it is a huge amount of data. So this should be at a high speed data transfer so that I can access my data continuously without worrying about the speed, and should be of a low latency, that at the time when CPU is trying to pick up the data, it should reach in lesser amount of time. Third, my CPU wants to write to the memory and to read to them from the memory. At the same time, I want these both operations at the same time. Simultaneously, I want these two operations. So over here, AXI comes into the picture. So these all three are our requirements which we needed. So here AXI fulfills these requirements very easily. How? You'll get to know in the upcoming slides and in the upcoming videos when we will be completing this module. You'll get to know how these conditions are being fulfilled by AXI. So what exactly is AXI? AXI stands to Advanced Extensible Interface. This is a high performance bus protocol. High performance, we know that it performs at high speeds, high amount of data transfer it can do. So when we say bus protocol, that means between master and slave there are a lot of signals which are being connected to master and slave, and these all signals work together. These are a set of signals. This set of signals works together following a transfer rule, or we can simply say traffic rule. The data itself is a traffic, and these signals combined works to make a transfer happen following some traffic rules. So that's when a lot of signals are combined, then we say this is a bus protocol. It is developed by ARM as a part of ARM specs. ARM stands to Advanced Microcontroller Bus Architecture. So what ARM deals is, whenever you are having one SoC, or I'll simply say in simpler words, let us say you are having a CPU architecture. Among CPU you might be having different modules and you want to connect them together. So the connection which are being established, majorly these ARM specifications are being used to connect these modules. So AXI is a part of ARM specification. It is a high speed protocol. It transfers data at very high speed. It has low latency. It provides the data at the same time when it was requested. It instantly provides the data. It can transfer data between master and slave. At same time, read and write can happen. It supports outstanding transaction. When we say outstanding transaction, that means from master can send lot of requests to slave, and slave one by one it can process those. So meanwhile master can send another request, so there the request can be queued. So these are outstanding transaction. Out of order transaction it supports. Out of order, when we say between master and slave, you might have sent transaction 1 at first, then second, then third, then fourth. Your transaction 2 is processed first, transaction 4 then processed, then 1, then 3. So AXI supports this. Doesn't matter which transaction you send first. If another transaction completes first, AXI will let you know with the response. So it also provides you response. AXI provides us responses that this particular data sent by you is being processed. It gives you the conformity by sending responses. Next, what we are having is our AXI channel architecture. So how AXI is being made internally? Between master and slave, AXI supports 5 channels. Channel number 1, it is what we call write request channel. It is denoted by AW prefix. Via this write request channel, we send the address with some control signals where we want to write the data. Then in the second channel, this is second channel, we send the data which is to be written into the memory with some control signals. These control signals are used to synchronize, to manage the data, to make a understanding between master and slave when the data will be coming, how the data will be coming, what are the rules for the data transfer. All this will be done using these control signals. Then we have a channel number 3, that is response channel. This response channel sends you the responses that your read has been done successfully or not. It also contains some of the control signals. Next we have our channel number 4, that is our read request channel. So this read request channel is the address from where you want to perform a read. So this is read request channel. The channel number 5, this channel will give you the response plus the data which you have requested, the data which you wanted to read. So now you see these 3 channels are based for write data. These 2 channels are based on reading of data. So as we know, separate channels are used for read and write. So that's why we said in AXI, reading and writing can happen side by side without interfering each other. The signals in AXI, these are global signals, clock and reset. The clock and reset is being applied to any digital circuit to make it work. AW valid and AW ready, actually these are valid and ready signals. If you see, these are common among all the channels. These are signals belonging to write address channel. These signals from write data channel. These signals from write return channel, that is, or write response channel. These are the signals based on read address channel. These signals are based on read return channel or read data channel, you can say. So if you see, these all signals are common among all the channels. So these signals are common because we call them handshaking signals. These handshaking signals are used from between master and slave. Master says, I am sending the data, and then slave says, I am ready, you can now send the data. So this is a communication between master and slave for which these two signals are being used. So how handshaking happens, we'll explain you in the upcoming video. So in write address channel, what we actually send is, we send the address. In write data, what we send channel, we send data. In write response channel, what we receive is response. In read address channel, what we send is our address, the address from where we wanted to read the data. In read return channel, what we receive is read response and the read data. So these other signals are control signals and the configuration signals, which I'll be explaining you when I'll explain you the whole write address channel. These other, you can see, these all are control signals. The control signals which we are talking about. We'll be understanding each and every channel in detail separately. So in next video, upcoming videos, what I'll explain you guys is, I'll explain you handshaking in AXI, how using valid and ready signal handshaking happens. Then I'll explain you the write address channel, then write data channel, then write response channel will see, then read channel will see, then the read data channel, read response channel, read response and data in the same channel, how it happens, we will see it all, and some additional concepts we'll see, that is ordered and unordered transactions we'll see. Then we'll see aligned versus unaligned addresses, we see outstanding transactions, we will also look what are they, how they are performed, how they are being serviced via AXI. So keep continuing, keep learning, keep following. Thank you.